Hello and welcome to another OpenShift Commons briefing. I'm Diane Mueller, the Director of Community Development for OpenShift, and I'm really pleased to have with us today Joe Fernandes and Mike McGrath to give us an update on the roadmap for both OpenShift and Atomic. As Atomic is upstreamed into OpenShift, it's a very integral part of our project. So I'm going to let Joe kick it off, and I think Mike is going to come in about halfway through, and we'll have Q&A at the end, or you can post things in the chat. We'll have a conversation after, and you can ask all of your questions then. All right, thank you very much, and here you go. Joe, take it away.
Great, thanks, Diane. So as Diane mentioned, my name is Joe Fernandes, and I lead product management for OpenShift. So we're going to talk a little bit about OpenShift and Atomic, and I'll start with kind of an explanation of how they relate to one another and both upstream and commercially, and then talk about sort of where we're at from a roadmap perspective and where we're going in this upcoming year. Hopefully give you some insight into some of the things we're working on in the community, and also things that we're getting asked about by our users. So all OpenShift and Atomic are part of Red Hat's container solutions, right? And so this slide kind of just covers that. Really, types of things we're focused on is how to help customers leverage containers and container-based platforms to modernize application delivery, bring greater agility to both traditional applications as well as newer cloud-native apps, drive consistency through the lifecycle from the dev and test environments all the way out to production, and then ultimately deploy those applications anywhere where they want to run. So, we talk about hybrid as being sort of the predominant architecture, and for us, hybrid could mean, public cloud and private cloud. It could mean multiple public cloud services. It could mean, virtualization or even bare metal. We want to be able to run across whatever infrastructure or whatever combination of infrastructures customers want to deploy their applications on. So starting with Atomic, really, Atomic started out as Atomic Host, and Mike's going to talk a little bit about what we're doing there. But Atomic Host is a variant of our Linux family, right? Of Red Hat Enterprise Linux. It's really optimized for running containers. So both Red Hat Enterprise Linux and Red Hat Enterprise Linux Atomic Host, which are the the Linux offerings that we provide, both of them now can run Docker-based containers, right? So our container runtime and packaging that we've standardized is the Docker container runtime and packaging format. But you need more than just containers and Linux to build out an enterprise container infrastructure. So as we've talked about in prior calls, beyond these two foundational pieces, you also have the need to orchestrate containers across multiple hosts and to manage that cluster. And for that, we do work in Kubernetes and basically bring that in to manage those container resources across the cluster. But even that is not sufficient, right? Because when you're running containers on a cluster and you're dealing with containers each having their own IP addresses, you need to be able to manage the networking of those containers across the various hosts. You also need to manage things like storage. If you want to run stateful services in containers, you need to store those container images in a registry. You may be interested in different telemetry like logs and metrics, and to gather info on how containers are working, and you need to sort of manage the security of the containers and the applications that run inside. So all of these are challenges that customers face when they're thinking about moving beyond just Docker on the desktop and thinking about Docker in the data center, right? Containerized data center infrastructure that can be used to run enterprise applications. And so we bring that all together under the Atomic brand. So upstream, that's Project Atomic, as well as projects under that umbrella that we work on, things like Docker and the Docker community, Kubernetes, For telemetry, we do work in the Elk community in Elasticsearch and Kibana, which are now part of the solution. We also, on the networking side, we leverage Open vSwitch. And so all of these things sort of are part of that container infrastructure. And then commercially, we announced in September a public preview of something called the Red Hat Atomic platform. So the Red Hat Atomic platform is the packaging of the components that you see here that we will soon be offering as sort of a standalone commercial subscription that you can get from Red Hat. OpenShift then kind of takes all of that entire infrastructure and then adds additional functionality to build out a full container application platform. So this includes things like self-service capabilities for your end users. So if you've ever seen on prior calls demonstrations of OpenShift, whether it was through the web console or command line interface or the work we're doing on Eclipse tooling, these are all part of the self-service interface that we built on top of this infrastructure. We also then build out different options for middleware and data services and publish them through a service catalog so that developers can consume those services. And we'll be talking about kind of where we're going with service catalogs to actually allow them to consume other services. And then ultimately, it's about how do you manage the applications through the lifecycle, right? So when you're running applications in containers, every time you change the application, you're not making the change in the container, you're actually changing the image, the Docker image that generated that container, and then instantiating a new instance from the image. So being able to build new images efficiently, being able to manage updates to those images when you need to update the application or deploy new code, and then being able to manage the deployments across the lifecycle, as I mentioned, from dev to test to production. Those are some of the things that OpenShift adds that beyond sort of the Atomic infrastructure to provide you an end-to-end platform. So there's even more still, right? So beyond the platform that you see there in the center, we're also working on a set of developer tooling, and I know there was a previous Commons briefing, I believe, maybe before the break, where we talked about things like CDK, our Container Development Kit, which is basically a tool that allows developers to run containers on their local machine and then upload them to OpenShift or Atomic, and that's going to feed into a full development studio that ties the Container Development Kit into other dev tools like IDEs and so forth. And then on the management side, we tie these things into Red Hat's various management solutions, whether it's CloudForms, which is our hybrid cloud management solution, Ansible, which Red Hat recently acquired for configuration management and automation, and then Red Hat Satellite. So kind of all of these things combined, bring this together. And then on the infrastructure side, obviously, OpenStack and Red Hat virtualization and are options that basically you can run this on, as well as running it on any of our certified public cloud providers. So again, the work we're doing now in containers really touches all of the products in the Red Hat portfolio. So while we really drive the roadmap for the stuff in the center, we also work closely with our team who works on our management solutions, our development solutions, and on other infrastructure solutions like OpenStack, like storage, like KVM, and so forth, to make sure we have sort of a consistent and well-integrated platform across the board. So in terms of our roadmap, this is just a high-level picture, right? So our journey really on this new platform started in June of last year when we released OpenShift 3, and that was sort of the culmination of nearly 2 years worth of work to sort of rebuild the OpenShift platform on this new Docker and Kubernetes base, as well as on RHEL 7 and the new Atomic host. And then in the fall, we put out our first point release of OpenShift Enterprise, and also put out the Atomic Enterprise platform public preview. So So with each release now, you'll just see a number of features and enhancements. But if you're downloading either OpenShift Enterprise or the Atomic Enterprise platform today, or you're pulling the latest community bits from Origin, you'll see features that were introduced in the fall, whether it's features around auto scaling or enhancements on the UX side, new middleware services that are now available, the Elk Stack integration that we added for logging, enhancements in storage and networking. So quite a lot went into that point release. And that's just, now we're on to the next, right? So in the bottom right, what I'll focus on today is just a few of the things that we're working on in the first half of this year. So for those of you who've kind of worked with us upstream, you know that we do development on an agile Scrum-based model, but we typically plan on half-year cycles, right? So while the development happens Scrum to Scrum, we know as we sit here today that there will be a 3.2 release targeted for early this spring, and then another point release 3.3, which will come out right around Red Hat Summit or shortly after, and that's this year. That's end of June. So around end of June or July, you'll see a 3.3. So we kind of plan them both together, and the features there kind of represent stuff that's going into each of those releases. Obviously, the things that take longer will end up in 3.3. Things that we can get out sooner will be in the 3.2 release. So we don't only think in terms of release versions and timeframes, we think in terms of themes. So these are some of the themes that are driving the work we're doing in the first half of this year. One of the biggest things that we're doing is sort of bringing our last solution to the V3 platform, which is OpenShift Online. So commercially, you can get OpenShift in three ways. You can get it as a software solution, which is OpenShift Enterprise, and that's been on the 3 platforms since last June. Current version is 3.1. OpenShift Dedicated is our second offering. This is a public cloud service that Red Hat runs that's basically single tenant, which means each customer gets their own OpenShift cluster, their own dedicated instance of OpenShift for just running their applications. And then OpenShift Online is our multi-tenant, public cloud service. And this is, some of you guys may have worked with this at OpenShift.com. Currently, that's still on our V2 architecture, but we've been working hard to get that onto the new V3 platform. So developers who are consuming OpenShift in the public cloud can get the latest and greatest capabilities that we're providing on-premise and in the dedicated offering. And then the other bullets here represent different areas that we're working in. I've included tags and parentheses. So if you follow our Trello boards, you'll see that we have a roadmap board where we sort of outline some of these themes or epics, and then through tags, like what you see here, they'll link out to user stories on the team boards. Right now, there's as part of Red Hat's overall engineering effort, there's, I believe, 15 Scrum teams, 14 or 15 Scrum teams working on OpenShift and Atomic, and they're each working in their respective areas. But a lot of these features span multiple teams, right? So through this tagging mechanism, if you're trying to follow development in Trello, you can start from one of these themes and then drill down into the various user stories and engineering work that goes on. So certainly we're continuing to drive our developer experience, through for OpenShift itself. We're working on our build and deployment capabilities, tying into continuous integration and working towards a continuous deployment model on OpenShift itself. At the Kubernetes and Atomic layer, we're working on something called service linking, which I'll cover in a second, and that leads into sort of being able to publish out catalogs of services for users to consume. We're adding Red Hat Mobile as a new set of services for OpenShift users, and then expanding into additional products in the JBoss middleware portfolio. we're working on our integrated registry to add more enterprise registry capabilities. I'll get into that, and then Mike can elaborate on that as well. Continue to work on scale, right? Larger size deployments, more nodes, more users, more instances, and so forth. So doing quite a fair amount of performance tuning and scale testing and so forth on the platform and on components like Kubernetes. Various efforts around container security, which is really both in Kubernetes and upstream in the Docker community, and getting into how to automate the provisioning of clusters, so multi-node deployments and so forth, and then the overall install and getting started experience and so forth. So this isn't a complete list. I think there's a couple of things I missed, but kind of shows you some of the bigger areas where you'll see work underway. So I won't be able to cover everything here, but I'm going to give you some of the highlights. In terms of the user interface enhancements, so we continue doing point work on the OpenShift web console to allow you to do more things through our browser UI, right? So ultimately our goal is that everything that you can do through our API and through our command line interface, you should also be able to do through our web UI. And so this is just the next set of things, whether it's being able to specify resource constraints on your pods, delete entities like projects and pods and so forth, add routes to a service, display and attach storage volumes, view more metrics, this time on build times and so forth. These are all things that you'll see, and I've kind of marked a couple of them actually got into a ZStream release we're putting out this month, which is 3.1.1. Many of them will be in 3.2, which is spring timeframe. I'll say March/April, because so that way development doesn't get mad at me for giving a specific date, but probably talking late March to early April on the 3.2 timeframe, and then 3.3 would be sort of late June to July timeframe, and we'll have more specific dates as we go along. The other thing is kind of introducing new UI. So deployment pipelines is a concept that we've been talking about for a bit, but this is the ability to, through the UI, visualize your applications from the standpoint of the stage of the life cycle that they're in. If your applications are running in a development environment and then you promote them to test or you promote them to UAT or prod, being able to map applications to environments and then watch the deployment across various stages. That's something that we've been doing a lot of thinking about and are bringing not only to the UX but to all the underlying supporting infrastructure. Service linking has to do with making it easier to attach one service to another service. So as an example, if I'm in OpenShift and I create a Node.js application, and you can start that up, you can scale up additional instances, then you want to attach it to, say, a database, MySQL. That you can do that today. It's just it's not as easy as it could be, right? If you don't have a template predefined to make those connections, there's a bit of manual work to sort of have one service talk to another service, and we just want to make that as simple as add a service to Node.js or attach a service. So the concept of service linking, whether you're inside of a project, whether you're working across projects, this is a common use case. Maybe I'm a front-end developer working on UI, but I need to consume some back-end services that someone else is building, and they're working in a different OpenShift project or Kubernetes namespace. I want to be able to add those back-end services to my front-end service. That's another use case for this. And then linking to services outside of OpenShift. So if I want to attach to a database somewhere else in my data center or a service that I'm consuming in the public cloud. These are all things that you can do today. It's not that you can't do them, it's just making that easier. And then from service linking, that you get into sort of being able to predefine those links and be able to publish them through a service catalog, which is sort of where this goes next. And then from service catalogs, you get into being able to do billing and metering in terms of a marketplace. So this is sort of a step on that. And I know Diane's been working on an upcoming Commons briefing just to talk about this particular feature, because there's been a lot of interest among our customer base and in the community around what we're doing here. YAML editor is just when you do have to default to editing a big build config or a deployment config, this is something that we added or adding to the UX so that you can do that, some of those config changes through the browser versus having to go outside. So beyond just sort of like the front end developer experience, and by the way, there's corresponding work on the command line interface as well on the underlying API. So for example, on auto scaling, we added auto scaling support in 3.1. We're enhancing that in 3.2 to be able to scale on additional metrics, but being able to configure that through the web console is also work that's targeted here, particularly for the June release. So build automation. So as I mentioned, when you deploy an application in a container, at some point that application is going to need to change, right? You're going to need to add more code. You're going to need to modify the config. You might need to patch the base runtime, and for any of those changes, what you want to do is actually not modify the running container, but actually build a new image, right? So essentially, Docker build at the lowest level, but you want to build a new image that has those changes and then deploy new instances out to your cluster to reflect that change. There's different ways that you can do builds. So in the initial release of OpenShift 3, we had a mechanism called source to image, and we still have a mechanism called source to image, or S2I, that allows you to do a build from source. So you provide source code, and or you push your source code to a Git repository, and either manually or automatically a build will be triggered that takes your source code and then does the application build as well as the image build, the Docker image build. So, for example, if you're pushing Java code to Git, we do the Maven build and pull all the dependencies, and then take those Java binaries and then put them into a Docker image, right? Do a Docker build. So there's really two parts to that build. There's the application build, and then there's the image build. Well, in the case of Java specifically, what if you already have binaries created? What if you already have WAR files or jar files from your existing build systems, from your existing CI? What happens next? Well, you still need to get those binaries into a container to run them. So at that point, you have the first half solved, but not the second half. So we've had this concept of being able to build from a binary, and that's something that we're enhancing, right? So kind of the original mechanism in 3.0, you still had to go through Git, so you'd push those binaries to Git the way you push source, and we can build them from there. In 3.1, we introduced a command that allowed you to push the binary via CLI, so you could bypass Git and just start a build from a specified file or directory that you pass us. And then we're working on pull-based mechanisms, improving the documentation, the functionality around building from binaries that you send us, that you specify for us via your Docker file or assembly script. So that's a big area, as well as then tying that all through your CI system. We have a Jenkins image for folks who are using Jenkins, but we want to actually ultimately work with whatever CI systems customers may already have in place. So you'll see other things here, but this is probably one of the big areas for our developer experience team, is to sort of continue pushing forward on build automation and CI integration. And then from there, you get into CI/CD, from continuous integration into continuous deployment. And this is sort of the deployment pipelines work that I mentioned. So we want to be able to visualize a pipeline. So in the near term, we're working on UX to visualize a pipeline and different stages within a pipeline, be able to interface that at least through Jenkins, so that you can sort of tie that pipeline to our Jenkins builders, and then use that to promote. Longer term, we're actually kind of continuing to build on that to do more complex workflows, right? To basically be able to do more elaborate pipelines and be able to trigger like automated promotion via different actions. We're adding more middleware and mobile services. I'm going to try to move along because I just realized we're running a little bit behind. We want to add more middleware and mobile services. So as I mentioned, the Red Hat mobile application platform is a Red Hat commercial product that's based on Feed Henry, which was a company we acquired more than a year ago now, which now forms the basis for our mobile solutions. There's a new version of JBoss EAP, which is our enterprise application platform, the commercial JBoss app server. So EAP 7 is coming out this year, and that'll be available in OpenShift. BPM is the Red Hat JBoss business process management suite, which will be integrated this year. And then API Man and Keycloak, these are both open source projects. Right now, we're not selling them commercially, but they're actually going to become products in the areas of API management. And then Keycloak is a single sign-on authentication solution that will be Red Hat will be productizing, and those will both be services on OpenShift this year. Dropping down into the infrastructure layer, I mentioned enterprise registry capabilities. So at the Atomic layer, OpenShift and the Atomic platform include an integrated Docker registry. So this is a standard Docker V2 registry. That's where all the images live, and that's where we store new images that we build when you're working in either of those products. So we're going to continue enhancing that registry. But what we're doing is adding features to allow administrators to better manage images in the registry. So there's a user interface that will allow you to actually inspect and see what images you have. And then we're adding administration capabilities around allowing administrators to control access, import new images into the registry. And ultimately, we'd like this to be something that you could use on its own. So if all you're looking for from Red Hat is a standalone registry to better control the work that your developers are doing, you should be able to do that. And then ultimately, from there, you can expand into the full set of functionality that OpenShift provides, Atomic provides, because that'll be the same registry. So continuing to do work on storage. So storage is basically how do we mount volumes from a storage cluster to containers that need them. So if you're running a database, like I mentioned, MySQL or Postgres, if you're running a database in a container, for example, you don't want to store your data in that container because the container is ephemeral. So we use Kubernetes storage volumes to mount storage from a storage cluster into those containers. Some of the things that we're working on, in this first half of this year is things like dynamic provisioning of persistent storage volumes. So for storage solutions that support dynamic provisioning, you could actually create those storage volumes on the fly as developers request them. So AWS, Google, and OpenStack are three that support that. And then we're getting into things like being able to define storage tiers via labels so that you can have different classes of storage and then make those available to different users. Maybe a lower class of storage for dev environments, maybe a higher class of storage options for production environments, let's say. And then we're adding more storage plugins. So we added a number of plugins in the last release. So we now have options for things like NFS and Gluster and Ceph and iSCSI and Fiber Channel and Amazon and Google and Cinder. Azure is the next public cloud storage option that we're adding. And then we're enhancing for specific storage solutions like NetApp and EMC, kind of enhancing the existing plugins that you would use to tie into those to do more specific things like dynamic provisioning or other provider-specific features. Continuing to do work upstream in the Docker community, right? So all the containers work we do is actually not in Atomic or Origin, or most of it is actually in the Docker community itself. There's a major new release of Docker 1.10 that's coming out imminently, and we'll be integrating that into the latest releases of OpenShift and Atomic. User namespaces is something that came out in the fall. It's in experimental, so it's not full production yet in Docker, but it's in the Docker experimental channel. But this is the ability to take containers, take processes and containers, make them, allow them to run as root, but then map them to non-root users on the host, so that basically you can allow processes to run that require root privilege without compromising the host, without risking the host by allowing that process have root on the underlying host. So still a bit of work to do there. I think there was a major step forward here last year, but still a bit of work to continue polishing that in Docker as well as in Red Hat Enterprise Linux, the corresponding capabilities at the operating system to leverage it. Image scanning, the ability to scan images. This is basically something that we've been working on, a feature called Atomic Scan that's integrated with SCAP. We'll be productizing that this year. We're working on optimizing the size of our base images for RHEL. So the RHEL 7 and RHEL 6 base images around which many of our Red Hat containers are built. We're working on that, as well as things like SE Linux support for overlay FS, and then more work upstream that's ongoing around image signing and notary. Kubernetes, I already mentioned the auto scaling and service linking. Pod idling is another feature. This basically is something that we had in OpenShift and V2 that we're bringing to V3, which allows you to essentially take a container that's not being actively used, it's not being accessed or modified, and then idle it so that essentially you free up the resource to run other containers. So we're driving that capability upstream in the Kubernetes community, and it's something that I think we're looking forward to bringing into the OpenShift and Atomic offerings. And then I'll leave it here with Atomic Host because I know Mike's going to get more into this, but Atomic Host, as I mentioned, is the optimized Linux, container optimized Linux OS that we introduced last year as Red Hat Enterprise Linux Atomic Host. And there's more work that we're doing as we continue to evolve that. And I think with that, I'm going to stop sharing and let Mike take over because I know he's going to be talking more about Atomic Host and some of the other features we mentioned. So.
I want to go over some of the Atomic Host and OS tree, and basically try to dig into what all this stuff is, and then touch a little bit on Atomic Enterprise Platform, as well as OpenShift and how they all relate to each other a little bit deeper. I have some architectural diagrams that I'll be going over as well, which I think will help take some of the feature topics and the slides that Joe went over and kind of dig them down into something that you might use inside of your own environment. So Atomic Host, as Joe said, is our container optimized operating system, and we have 3 flavors of it today in Fedora, CentOS, and RHEL. We're doing something new in Fedora with it, and it's kind of a fairly recent thing that this actually started happening, but we're releasing a new version of Atomic every 2 weeks. And so it's free. You can go and check that out right now and download them. It's always got the latest and greatest Docker bits in it that we have, and you can always check it out there. Now, CentOS tends to be a little bit slower there and tends to still be rebuilt from the RHEL Atomic host, but it's also free. And by slower, I mean it's not released as often. And then finally, you've got the Red Hat Enterprise Linux Atomic host. And that one gets updated every 6 weeks or so. It's got a full release cycle, totally enterprise ready. And so I think the first thing most people realize when they look at these hosts, especially if you're familiar with Fedora or already a RHEL user, is how quickly we're updating these. You know, this is a very different model from what we've done in the past. And so it's very helpful for DevOpsies and DevOps and developers who want the latest and greatest, either in Kubernetes or Docker or whatever. We're really making strides to make sure that they have that in a supported and enterprise friendly way. So the first thing about Atomic Host, if you haven't looked at it, is OS tree, and it's the magic that makes Atomic different from regular operating systems. So there's no yum in it, and it changes how you do updates. Basically, if you have an Atomic Host, you have to run the Atomic command to do the updates. And so if you want to move from, say, version 7.2.1 to 7.2.2, you run Atomic Host update, and when you're done with that, the system will still be on the previous version. You actually have to reboot to pick up the changes. Significant portions of the file system are read-only, and generally this allows you to think differently about your infrastructure and give you a better way to do updates. And especially in troubleshooting, you generally don't even have to try to fix a host in some of these immutable situations. You can just reboot or rebuild, and that is almost always going to be faster than trying to fix something. So keep that in mind. One of the other core components that goes into Atomic Host is Kubernetes, and AEP, the Atomic Enterprise Platform, and OpenShift both rely on Kubernetes for their orchestration, and they do this across several nodes. Just to give you another view for those of you that aren't familiar, it's got a full RESTful API. It's got some application templates built in, health checking. It has a full self-healing infrastructure. It's totally extensible, and you will see how much we've extended it. And there's also resource limitations that are built in, and scaling is something that gets built in so you can easily add or remove new containers. etcd is what we're using on the back end to store configuration and metadata. It's a basic key value pair, very simple to interact with. It's fast. It has consistency and resiliency built into it. And so if you haven't looked at etcd, it's worth a view. Now, the core of everything that we're doing here in the container space is Docker, and we rely on Docker for our imaging format. This is also what we're using today for our container namespace. It's also our distribution mechanism. Docker has this full layering process built into it, and of course, the process control comes with it. So hopefully, I don't have to go into this into too much detail. I do have a quick demo later for those that haven't really looked at Docker, and just a quick way to get started using some of Red Hat's technology. So Cockpit is something that gives a UI to individual Atomic hosts. So if you have an Atomic host and say you don't really know Linux or Unix that well, you can still use all of this stuff. Certainly there's a lot of developers out there who are building things in containers on Windows machines and on Mac machines. And maybe they don't even really know that much about Linux, but they do know they want to build things in containers with the extensive container ecosystem that's out there. Well, you can still build all those things in containers, and you can still have a reasonably functional and customizable Linux host using Cockpit without having to know any Unix at all, right? You can just use the UI, and I'll give a quick demo of some of that in a little bit. And of course, there's the deployment. And so the basic steps, and this is kind of the important distinction between Atomic Enterprise Platform and OpenShift is that in Atomic Enterprise Platform, you have to create your container somehow, you push it to the registry, and then you have to create an application manifest, and that application manifest then pulls down those existing images. And so the input to an Atomic Enterprise Platform setup is the manifests and containers. The flip side of that is OpenShift, which supports that exact same deployment scenario, but it also allows for one additional input of source code, and that's that S2I, the source to image bits that Joe was talking about earlier. Once you're able to start providing source code, it completely changes the game for you in terms of being able to have a fully end-to-end developed workflow where developers can provide source code. It gets built and tested in the system and deployed to production, and it provides that full DevOps experience, which is, I think, really great. So the final component that we didn't talk about yet, which is the thing that makes Atomic Enterprise Platform and OpenShift so great, is Origin. Now, Origin is the upstream community process that integrates with Kubernetes, and it extends a lot of those features of Kubernetes. And so for those of you that are wondering, well, hey, I've used Kubernetes now for about a year. I watched it when it came out about a year and a half ago, and I really like it. Why would I use OpenShift or Atomic Enterprise Platform over just a regular Kubernetes? And so Origin is the answer to that. And it integrates very heavily with Kubernetes, and it leaves the Kubernetes there. The normal Kubernetes is still a part of all of this. It's just that we extend that Kubernetes functionality with a far more extensive user management and role-based access control system. We add the concepts of projects. Origin also allows us to add custom registry and router implementations. Adds things like image streams, and of course has a full template creation system, which is very important in any sort of advanced application where you need to tie several containers together. You're going to need some way to do that, and this template creation system has the answer. So if you want to look at a basic architectural diagram, this is what it looks like. On the left here, you can see the OC person. That's the OC client tools, which come with OpenShift and Atomic Enterprise Platform. That is your primary interface to an Atomic Enterprise Platform installation. And it connects to the Kubernetes / Atomic Master that also has the Origin API. All this is RESTful, and that's your interaction. And so once you send some job to the Kubernetes and Atomic Master, the rest of it's handled by the system. It goes out to the Atomic node. It can deploy and pull down your containers as needed. It will do whatever health checks you need. All you have to do is describe your application, and the system will go and try to deploy the containers as needed and keep them deployed. If something fails on the back end, it will try to redeploy the containers, all of that stuff. One of the other nice things that we add at the Atomic Enterprise Platform level is that we have the Atomic Registry, which Joe talked about a little bit. It can actually run inside of a container in the system, as well as an HTTP-based router, which we're looking to extend and make even better all the time. Right now, it's based on HA proxy. In the next slide, you'll see we have OpenShift, and it takes all of that same core functionality and adds even more to it. And so you'll notice that the user now has an option to use a UI to interact with Kubernetes and the Atomic Master, in addition to the original OC tools. But it also adds the STI builder, the Docker builder, which is very important if you need to rebuild images. So let's just say that you have no application change to make, but maybe a shell shock happens or something in the underlying container images needs to be built. The Docker builder image can then rebuild those images automatically and deploy them instead of having to go through and doing that manually. It also includes some CI integrations that are great, the Docker registry, and it still has that same HTTP router. So first, I want to look into a quick example of what these templates look like if you haven't seen them already. The first is an example from the upstream Kubernetes repo, and there's tons of examples up there already. I'm just going to pull down this one, which includes several different little containers that it deploys. The first is your basic hello world template. And so if you look at this example, this is kind of your basic template example. And I had word wrapped it before, but this actually will go through and you can copy this into a file, and it has all the information that OpenShift or AEP needs in order to create this application. The first, just to give you a view of what some of this config file contains, first, when you deploy one of these things, you have to tell it what kind of component you're deploying. In this case, it's a pod component. The next is the name of the pod. You have to name it, and so ours is going to be Hello Atomic. And then you have to tell it the image. Now, these images are those Docker images, and this is the part of the deployment config that maps the application desires to an actual container. And so, in this case, that Hello Atomic container already exists out in the Docker Hub somewhere, and it's ready for download. Next, you have to do some mappings. And so we know that this container internally listens on port 36061. And we want to expose that to people, customers or whoever, on port 8080. And this is the mapping that does that. Finally, in this example, we run the OC create command that pulls in that hello pod JSON, and it sends that to the server via the REST API and creates the pod. It's very easy. Once it's done downloading telling the node to download the image and start it, you can then run an OC describe on it to let you know which IP address this is now listening on. And in this example, it got posted to 10.1.0.2. If you remember from the earlier example, we exposed that port on port 8080, which means that we should have some sort of application available on port 8080. And you can see that by running the curl command, you've got a 10.1.0.2 port 8080 Hello Atomic setup there. So the next thing I want to show is something that, just a little teaser of something we've been working on, which is some of this visual boot stuff. And the concept of this is just the quickest possible way to get started with Atomic. So let's just say that you happen to be at this Commons, maybe you saw it on Twitter, you're not really sure what we're up to, or maybe even not really have used Docker before, but you want to give it a try. Well, there's a virtual machine image that you can download on projectatomic.io, and you can actually run that image, and that's what I'm going to do here. So I'm going to hit play, and at the boot prompt, if you're not familiar with Unix, there's a grub prompt, and you can kind of select what you want to boot into. And by default, it'll boot into Fedora 23 mode. And I'm sure that this is a little bit small. I apologize. I don't know that I can actually make it much bigger. Let me see. Can I? Yeah, that should be better. So in this example, we also have this sort of developer mode boot option that we can do. And so we'll select developer mode. At this point, what's going to happen on the back end is Atomic is actually going to boot like normal. And then once it's done booting, it will automatically download the cockpit UI code for this Atomic host and boot that. It'll also generate a password and everything you need in order to get started. And it will actually show you some of this in the background. And so it's actually going out and trying to download the pod now, or I'm sorry, the cockpit container now. And you can see that it's available at the top there. Get my mouse here. At the top here, it's available at 192.168.122.24 on port 9090. And this is the root password that it has auto-generated for us. So I'm going to flip out of full screen because we don't actually need to do anything in that container anymore at all. Let me just pull up that address. .22.24.9090. Okay, so as you can see, this is the cockpit interface that is booted in that virtual machine. I just need to log into it with the root address or root password that I've got. Now I can do all the things that you would commonly need to do on a Linux box without having to know the command line at all, without having to really know anything about Linux. You can provision storage, you can look at the logs, and you can even download and install containers. And so if I want to, in this case, I have previously downloaded the JBoss Wildfly image, and I can actually start that container if I want. So this is the community edition of JBoss. We know that it listens internally on port 8080, and so I can actually tell it to start this container also on port 8080. and I can run it, and it'll take a little bit to go and download and run. But once it's up, I can click, see that everything's looking okay, and then I can actually bring that image up all on my workstation and see that Wildfly is running. So it's a really quick and easy way to get just looking at Docker. If you haven't had a chance to look at it yet and see what it's all about, this is a really easy way to get started. And of course, that will take you down the rabbit hole of always wanting more. And so, you can go take a look at the CDK options that we have as well for more serious development. When you want to get out of the, I want to create a container mode and into the, I want to create an application mode. That CDK contains all of the build and developer tools that you would need, as well as OpenShift. And once we get the OpenShift online updated, you can also just go there and test out and try whatever you want. And so I think I've got a couple more slides, and then I'll hand it back to Dan. So in this case, we've got one thing I did want to mention is that Atomic Enterprise Platform is not quite yet GA. We do have a public preview that's going on, and so if you have a TAM or an SA, feel free to talk to them, or you can take a look at access.redhat.com. If you want something that we release, you want to try it out directly from Red Hat, and there's also community versions of Origin and OpenShift available. So it's really easy to download and try these things. And so with that, Dan, I'll hand it back to you.
All right. Well, thank you very much, both you and Joe. And Joe, that was a good introduction to the roadmap and the amazing amount of features that are getting put into the next couple of releases. And the Atomic explanation was perfect there, Mike. So we only have one question. Boris posted something, and I think that's more pointed towards Joe, about so since there is a finally push for online to move to V3, what is the likelihood of Red Hat releasing migration tools, or at least documentation on what the strategy is for that? And I actually think that's a great topic for another OpenShift Commons session.
Yeah. In terms of, so I'll talk to migration strategy first, right? So it is a side-by-side migration from OpenShift 2 to 3. There's no upgrade in place, and the reason for that is because really everything changed from like the base operating system. OpenShift 2 is on RHEL 6. In OpenShift 3, you're standing up either a RHEL 7 or a RHEL Atomic host cluster, and then things like the containers, the orchestration that we do with Kubernetes, these things are all new. What we try to keep consistent is the services that are available. So everything that you do in in V2 in terms of like the things we supported, like JBoss and Ruby and PHP and Python and Node.js, all of them have corresponding images in V3. So we have the same set of images, actually more images in V3 than we had in V2. For folks who created custom cartridges in V2 or customized our existing cartridges, that's essentially you're customizing the builder images. We have some examples of how to build images and how to work with the assembly scripts, but essentially the image is a Docker image, so you're modifying the Docker file to change the base image, and then attaching the assembly scripts. In terms of how we do builds, Mike mentioned source to image, and then I talked about how we're working on binary to image type enhancements. That's the same way that you could push source code to a cartridge or push binaries through our binary build interface in V2. So the goal is that, like, if you have an application, if you have a Java application or a Python application on V2, that it would just run in V3. The things that are going to require changes is two things. One is how you integrate the infrastructure. So if you're tying things like the networking to your DNS, or using an external router like an F5 or what have you, that's going to be a different configuration, hopefully greatly simplified. And then anything that you did on sort of like hooks, like pre-deploy or post-deploy, if you added any hooks, we have the same hooks in V3 or similar hooks in V3. And yeah, that's certainly something that we'd like to work with users on, and we'll certainly be working with a lot of users as we migrate the online environment and providing examples on that. So I think, yeah, maybe doing a follow-up on this topic, Diane. We'll talk about that as we so we can get into each of these areas, so people can map what they're doing today to what they would need to do to get those apps to V3. So
I think there's a lot of lessons learned at the OpenShift Online operations team, and
absolutely, yeah.
So we can get that going. We're almost to the end of the hour, and so I think the other thing that I just want to point out, I tossed in the Trello link to the Atomic OpenShift roadmap board, and if folks want to dive deep or look at where things are going, or even perhaps contribute to some thoughts and feedback and code to any of these areas that both Mike and Joe have talked about, this is a good place, a good starting point to take a look at a lot of these things. And like I said, there will be a service catalog session in February on the 11th. We'll talk about that. We'll set up something around migration. I think that's a great topic. Next week, we're going to be doing a session with BlazeMeter on continuous testing. So that should be very interesting as well. So we're trying to mix it up a little bit so that they're not all deep dives into roadmaps and technical stuff on the project, but also some of the services. So this has really been a great session for me. I know I've heard the roadmap explained a number of times, a number of ways, but this one actually worked quite nicely for me. So thank you both again for joining us today. And if you have questions, you can always jump on the IRC or toss them to us at OpenShift on the support at Stack Overflow. So just reach out and we'll be there and try and answer them. And we look forward to having you all again next week. So take care and thanks again, guys.